Hello, everyone. Welcome to Google Cloud Next 2023. Are you enjoying the conference so far? Awesome, great. Welcome to this session. I'm Vidya Shanmugam. I'm product lead in BigQuery, and I have with me our valued customer, Alban, who's coming all the way from France here. He's the director of engineering at Teads. Say a warm welcome to Alban. Thank you for joining us. Great audience, thank you. So before we jump in, I just want to quickly share what we'll cover today so you can see how this relates to what you're thinking about. We'll first talk about some of the great technologies we have here in Google Cloud that power cross-cloud analytics and workloads, including BigQuery, Omni, and Looker. We also have a cool demo to showcase some of these new features we have, as well as cross-cloud joins and governance with Dataplex integrated. And saving the best for the last, we'll hear from our customer Teads on their journey to BigQuery and BigQuery Omni from Redshift. So let's jump in. Let's start with data, right? This is the data analytics session, so let's start with some numbers here. Over the last decade, we've seen a massive explosion in data, both in data types, data volume. If you look at numbers in 2 years, we're going to be hitting 181 zettabytes. I had to Google what a zettabyte is, and it's 1 followed by 21 zeros. It's such a large number. It's 1 trillion gigabytes, so very, very massive. Where is all of this data coming from? From all of your applications, from APIs, whether it's transactional systems, whether it's streaming, or whether it's any form of batch processing systems. And with this volume and explosion of data and different types of data, it's sitting in different data silos in storage systems, whether it's warehouses, whether it's data lakes, object stores, relational databases. And more customers are also having this data spread across multiple cloud platforms. Majority of our customers and enterprises we talk to, they have data sitting in multiple clouds. Did you all know that 9 out of 10 organizations, they fail in their multi-cloud strategy? 9 out of 10 organizations. This was very, very shocking to me as, as a PM working on this area. And that's why we're all here to talk about multi-cloud analytics and learn some best practices. So let's dig deeper into these technologies. So how does Looker, how does BigQuery, Omni, all of these things come together? We talked about customers wanting to manage their data silos. They want to do more with their data sources here. And more customers want to combine them, understand the end-to-end data for data insights for their analytics needs. With BigQuery Omni, you're able to consolidate your data into a single pane of glass for your query, for your analysis, for your data transformation, for all your needs. With Looker on top of this consolidated data, then you have a robust, consistent semantic layer. You can visualize, you can explore your data, and with this, you power all your data experiences, all your different workloads. So what is BigQuery? Sorry, clicker on the wrong direction. What is BigQuery Omni? Many of you might have heard or tried BigQuery Omni, but I'll give a little bit of what the nuts and bolts of this solution are. BigQuery Omni is a fully managed serverless BigQuery offering that's running on AWS and Azure. What it essentially is compute that is running local to your storage. So it's accessing your AWS S3 buckets or your Azure Blob Store directly without actually moving, without actually replicating any form of data. With this, you have a single pane of glass to query your data at ease. You're also able to do a lot of cross-cloud joins, cross-cloud materialized views, which I'll talk about soon. With all of this data sitting in different places, you also want security, you want governance, and BigQuery Omni allows you to do a consistent and unified governance across all of your data sets here. So let's see with an example how this single pane of glass works, right? In this example, I have a fictitious gaming company who has several titles and player data sitting across AWS S3, Azure Blob Store, BigQuery Managed Storage, as well as GCS. These are all disparate data sources. They're all physically located in different locations. But what Omni allows you to do is see it all in the single BigQuery interface. It all acts as if these are native BigQuery tables. We are not replicating data. We are not copying any data. We are just providing you access to that data by BigQuery compute running in these locations, which means for data analysis, for anything with a single SQL statement, you're able to access all of this. This is as we've talked with several customers, super powerful because instead of you having to go into each of these platforms and query your data, move your data through data pipelines, we're giving a single pane of glass, single access. And what more, you can also set row-level, column-level access control and fine-grained access on these data sets here. Now next, I know it's very cool to go and look at all your data in a single pane of glass and maybe run ad hoc queries, but that's not enough, right? You want to combine this data. You want to do a lot more with that data. And cross-cloud analytics is where that comes in. So we have several capabilities in our portfolio for organizations to do cross-cloud analytics, and I'll be talking about some of them here today. So starting out with cross-cloud transformations. So you might want to query the data, you might want to locally transform them and bring only data set that you need for BigQuery for further analysis. So we have a capability called cross-cloud transform that allows you in a single SQL statement, query your AWS data or Azure data, pre-process them, filter them, and then create a table in BigQuery directly in one statement. So whether it's a new table that you want to create or you want to append to an existing table, we support both of these operations. Now, we are very, very excited. I need to figure out how to turn the clicker in the right direction. Sorry about that. So we are very excited to announce a very, very net new capability called cross-cloud joins. Cross-cloud joins is a single statement, direct cross-cloud join between two clouds. So in a single SQL query, you're able to now join a table that you have in AWS or Azure and a GCP table. No other cloud data warehouse vendor offers this capability. This is something we're doing by running subqueries on your behalf in the AWS data set, bringing only the relevant data you have here and joining it. How many of you are excited about this capability? Awesome. Thank you. We have this in private preview for you to try it out. Okay, I talked about cross-cloud transforms. I talked about cross-cloud joins. Great, I can ad hoc query some things, but what if my data is changing? What if I want periodic dashboarding, periodic reporting? I want to power up Looker dashboards that I want to use for my business analysis or executive reporting. How do I do this, right? I'm running ETL pipelines, I'm bringing my data periodically, what do I do? And so we have a net new capability here called cross-cloud materialized views that allows you to do just this. What cross-cloud materialized views is allows you to set up a local materialized view in AWS. You can specify your refresh intervals based on how often your data is changing. And then you can create a remote materialized view or cross-cloud materialized view in GCP. Once you have that materialized view now available in BigQuery and GCP, it's accessible to the entire GCP ecosystem. You can run analytics, you can use it with dashboarding, BQML, AIML, any form of operations are now available here. So this capability is recently launched, available in private preview as well for you to try out. Now, we talked a little bit about single pane of glass. We talked about cross-cloud analytics. What about governance? Several of your organizations, you think deeply about security, managing your data, thinking about access controls. So we have a very, very tight integration with Data Catalog and Dataplex, and that's what I'm going to talk to you here today. With integration with Data Catalog, you're able to seamlessly search your data, discover, enrich it with metadata with business glossary. You're also able to do fine-grained governance with row-level access and column-level access. And we have in the future governance rules coming, which will allow you to do this at scale. Lastly, we also support lineage. So whether your data is in GCP, sitting in AWS or Azure, once it's a big lake table, you can run lineage on it. You can track and understand your data assets. So the governance is not isolated. The governance is cohesive. It's unified. It's consistent, no matter where your data is. Wouldn't it be cool if all of these capabilities I'm talking about is available in a region close to you? So BigQuery Omni's regional rollout, we're rapidly expanding into several new regions, and very happy to say we have global coverage with our recently launched APAC regions and Europe regions. This summer, just a few weeks ago, we launched the EU Dublin region in Ireland. We also launched the US West region in Oregon. We have several more regions launching later this year, so we have global coverage and we're continuing to expand. I just won't spend too much time on this slide, but what I want to share is that We've heard your feedback. We've heard our customers talking about how cross-cloud analytics needs to be more powerful, more performant. And so this is a set of capabilities our team's been hard at work in launching in the last several months. We talked about the joins, the materialized views. We also now federate from AWS Glue catalog. If that is your source of truth and you want to keep that in sync, that's something we support here. We have query acceleration and performance acceleration now we support. We have support for Analytics Hub in Omni regions. I didn't put this on the slide, but we also support Iceberg and Delta format on Omni here. So with that, we have several new capabilities for you all to try it out. Now, how does this all come together? We talked about all of these technologies, but I want to bring this all together before we jump into a demo here, right? Our goal in GCP is to provide a cohesive cross-cloud analytics platform, which means there are multiple building blocks. Starting out with BigQuery Omni, I talked about how it consolidates your data across clouds in a single pane of glass. With Big Lake table integration, we have fine-grained governance, providing row-level, column-level access. For all of your cross-cloud analytics, for fresh, consistent data, we have materialized views, we have cross-cloud joins. Now that your data is all consolidated in BQ and GCP, then the power is yours, right? With Looker, with ML models, with Vertex AI, you can do anything with your data. So now you're taking the organizational data that's all siloed, which is not spread across different places, to now come together to power your analytics and insights for your organization. I'll pause there with that. I'm going to jump in. We will have time for Q&A later in the session, so if you have any questions, please think about it. We'll jump in there. So with that, I do want to show some demo on some of the cool features we've talked about, as well as talk about our unified governance here. Let's see. Great. I did pre-record this demo because we did want to cover several different features, and we want to bring that together in this short session here. So what we will be seeing here is a discovery experience. So as a data analyst for a fictitious organization, I know that symbol here, I know that I have orders data sitting in AWS, and I want to be able to go and discover that data. What I'm looking to do here is I'm going to then go into, I'm not sure if this is playing. Just give me a second. Oh, it is playing. OK. So yes, I'm going into the discovery pane here, and I'm going to look for order items data here. And what you can see is on the right side, this data and this table is coming from AWS, like I talked about. It's in a different cloud here. I'm going to quickly look at the schema for this, and this makes sense for me. I'm going to pause here for a minute to just talk about the joins capability that we had. So I talked a lot about cross-cloud joins, and I want to show how real it is here, right? So as an analyst, I know I have orders data that's sitting in AWS. This is my point of sale data. I have all my e-commerce data in a BigQuery table in GCP. And for me to be able to look at my holistic organization, look at my holistic order data, I need some fields sitting in AWS, I need some other fields sitting in GCP. And before this, I would have to actually run ETL pipelines, move my data, bring that to GCP for me to do that. Now, what we are showing here is in a single SQL statement, you're able to pull the fields that you need from your AWS table, pull the fields you need from your GCP table, and through a left join, actually create a consolidated data set. So this is the power of the cross-cloud joins that you all applauded me here for. So let's jump in and see how to create this thing. It's going to run here in a minute. So now it's processing. And once the table is created, you can see that I have fields sitting from AWS and fields that are here in GCP all in one consolidated table, then that's available in GCP for me to use. As I mentioned, you can use it with any of the dashboarding tools of your choice. You can use it with BQML, your ML models. You can take it to Vertex AI for your training. Now I've looked at the schema, looks good to me. All the fields that I wanted from my different sources are here. What if I want to do more governance aspects with it? I want to profile, I want to do data quality, and all of those features are something that I'm going to show here, right? So I want to understand that my data that I got from two different sources, as an analyst, I don't know what's in that source. It's statistically distributed, it's not too skewed, so I did a quick data profile scan. This does take a little bit time to run, but we fast forward here to the demo, so you can see that the quality is fine for me. What I'm going to then do is I'm going to set up data quality rules. I want to make sure that as new fields and new rows are coming in, they match a set of criteria here. So here are some data quality rules that have been automatically generated based on the profile we run. So you saw that it was recommendation based, so I didn't specify it. And there are some fields for null check. There are some fields to say, hey, it should meet the set of criteria here for one of these fields. So these are automatic rules that have been set on the combined data just based on recommendations. Without much effort from your end, it automatically pulls it. If you're happy, you can create this data quality rule. Make sure that any data that's coming in matches this. We have a scorecard which talks about how many of these rules have passed, how many of these rules have failed, and it'll give you automatic alerts as well if you set that up. So that's a bunch of things related to like profiling, quality checks. Now I want to do fine-grained governance, right? So if you jump to that part of the demo here, I want to set row-level access to a specific group to just say, these are the fields that I really want this user to have access to, no other fields. So I'm setting a row-level access here, saying that one of these fields of the terminal status is what should it return. I run this, and on the consolidated table, I would be running this as an admin. It will set that row-level access policy. Now let's go query this table and see what it's going to return for us. When I go query this table, you can see I already see a flag that only a subset of rows are returning. And then the fields that are here are matching the row levels that I've set. It's only giving me access to that, and all the other fields are hidden from me. So this is powerful row level and column level. Jumping further into lineage, so the consolidated table we know has data from GCP and data from AWS. So what you can see here is telling me the source and the flow for the data. So in this case, this table is from GCP. Going further to the order tables, this is the one that we got from AWS here. And if you see here on the right side, it's S3 bucket, that the source of the data, it's a Parquet file. So I not only can profile, scan, set governance, but I also can understand the lineage of my data and continue to track it. Lastly, what we're going to show is now I want to share this data with my organization, so I want to enrich it with some metadata. I can set a bunch of different fields, whether it's description, whether it's labels, whether it's expiration time. So once I set all of these fields, now I have my data set and ready to go and can be shared. So this is kind of the end of the demo, but what I want to quickly talk about, we saw a bunch of different things here. What I want to share here is that we started out with just knowing that there is a data set in AWS. We searched for it, we discovered it, we knew this is the data set we want. And then through cross-cloud join, we took data from there and from GCP, created a consolidated table. We ran data profiling, and we had automatic data quality, saw the dashboard there. Then we did row level and column level security. Here we saw row level with fine-grained governance. We also saw the lineage capabilities and then metadata enrichment. So all within this 5-minute demo, you saw how with BigQuery, with Omni together, you're able to do cross-cloud analytics. You're able to govern your data very holistically. So with that, I want to transition back to Alban here to come talk about Teads' journey. Thank you.
Thank you, Vidya. All of these announcements are really exciting, and they are particularly on point for us. Teads is no exception to the industry trends. And to illustrate that, I took the liberty to steal your very first slide. We have a large volume of data. It is increasingly distributed. It serves more and more use cases, and it's spread across all major 3 cloud providers. I'm Alban Perillat-Merceroz, and I've been working at Teads in Montpellier, south of France, for the past 7 years. In 7 years, Teads has evolved a lot, and so has its ability to deal with data. In 7 years, the 2 biggest additions to our data stack were the introduction of BigQuery and Looker. Today, I'll give you an overview of this data journey. What is Teads, and why do we need so much data? The tools and technology we put in place, including BigQuery and Looker, the challenges we have with cross-cloud providers, and finally, our single pane of glass dream. So, what is Teads? Teads provides an end-to-end online advertising platform. With Teads, brands are able to reach up to 1.9 billion users. And with Teads, publishers can monetize their content with advertising that respects their users. Now, providing advertising to 1.9 billion users generates a lot of data, and it requires a lot of data too. So data at Teads, it serves two major use cases. The first one is operational. To keep showing relevant ads to the right users, we need to collect data, to train machine learning models, and to use these models to predict user behavior. Most of Teads infrastructure is on AWS. To train those models, we use a mix of S3, EMR, and Spark. The second major use case is analytics. We provide data and insights to our users, to our clients through data exports and data visualizations, and to our internal users through a self-service BI platform. Analytics is the use case that made us choose Google Cloud 7 years ago. So let me show you a high-level recap of how our data stack has evolved over the years. So we started with AWS only, with a Spark-based machine learning framework. Then 7 years ago, we introduced BigQuery. Our primary goal was to provide a powerful reporting capabilities to our clients. Now, to provide data to our customers in a timely manner, it requires transformations, such as data aggregations. To do that, we introduced dbt, a well-known open source tool that allows everyone at Teads to describe these transformations in a standard way. These transformations are then executed inside BigQuery. Next, we needed to provide data visualizations in web applications. Unfortunately, BigQuery was not the right tool for that at the time. So we chose Redshift that allowed us to have lower latency and to support a higher concurrency. Then a major addition to our business intelligence capabilities was the introduction of Looker. It helps every Teads employee to take data-driven decisions. And lastly, tech-savvy users still have the options to run direct queries against the raw data using Athena, BigQuery SQL, or even Spark notebooks. I'll now take a bit of time to present two of these tools, which are BigQuery and Looker. There would be much to say about BigQuery, but in the interest of time, I'll only illustrate with this graph. Each line represents the adoption of one of our data technology at Teads, Spark, BigQuery, and Redshift. So don't mind the exact figures, they are made up, but my point is BigQuery is winning the adoption race at Teads. Now, why do you think is the number one reason for that? Is it more powerful? Is it cheaper? It's not, but it's definitely simpler. It's simpler to learn, it's simpler to use, and it's simpler to maintain. As a company, and as we grow as a company, it is becoming more and more important to provide simple tools that can be adopted by most people. And the simplicity of BigQuery has really helped us doing that. Now, Looker is our most recent addition to our data stack. We recently had to change our BI platform. So we compared many tools, and we ended up choosing Looker. Here are the three main reasons why. First is the Looker modelization layer. It abstracts the complexity of our underlying data. It is defined as code and versioned in Git, and it allows a centralized governance. The second reason is that it delegates the processing to the data warehouse. So it may seem a basic feature, but actually, most of well-known BI platforms are actually requiring you to import all of your data into their system. And finally, Looker's self-service exploration capabilities. It lets people interact with your models directly and be able to take data-driven decisions in a self-service way. Unfortunately, dealing with multiple cloud providers comes with its challenges. Here are some of the challenges we have. The cost of ownership of 3 tools, BigQuery, Redshift, and Athena. We also have many different ways to query the data. We have Looker, we have BigQuery SQL, we have Athena SQL, Redshift SQL, or even Spark notebooks. And finally, we need to maintain jobs to move and transform the data between clouds. So we can summarize all of these challenges into a single one. It is becoming more and more complex to deal with data. That's why we are now investing into reducing this complexity. Our goal is to rationalize our data stack. The first candidate to this rationalization is Redshift. So let me give you a bit of context on why we chose Redshift on top of BigQuery. Our goal was to embed data into interactive client-facing web applications. We expected low response time and a high volume of data, of queries. Unfortunately, in 2018, BigQuery was not the right tool for that. Redshift had a lower latency for small queries and was able to take more concurrent queries thanks to several small Redshift clusters. I'm glad to say that BigQuery has gotten better since, thanks to several enhancements in the resource allocation systems and some features such as the BI Engine. It is more realistic to use BigQuery for this use case now. So that's what we do. Not only it reduces the complexity our developers have to deal with, but it also removes the need to move data between clouds. So that's where we are today. Now, what's next? We still have too many ways to explore the data, and we still have too much cross-cloud complexity. So let me share my vision for the years to come. I'm calling this the single pane of glass dream. The single pane of glass is a single, simple way to access all the data, whether it's stored on S3 or BigQuery. So in this dream, we are using Iceberg as a table format for our S3 data lake. Iceberg is an open source table format that brings many interesting capabilities, such as ACID transactions and performance improvements. This format is supported both by Spark and BigQuery. In this dream, it is possible to cross-cloud, to join cross-cloud data for small queries, or to easily transfer data between clouds. And of course, all of this data would be accessible in Looker. So that's it for me. Thank you so much, Vidya, for inviting me on stage. And now I'm counting on you and your team to deliver on this cross-cloud vision and make this dream a reality.
Thank you so much, Alban. Thank you all for being such a great audience.